This video will be discussing sections B and C in Module 1. So we just got finished discussing section A, and we left off with a discussion on compression, where we talked about lossless and lossy. So we'll be seeing that discussion come up again. All right, so let's get started on section B. Just going to click on digital sound and open to this, first little introductory page where we see a little intro about all the different things that we're going to be learning about digital sound. See the section objectives. We won't take time to read through those. Lots of terminology in regards to sound here. And so let's just get started. Okay, I did notice a few things in going through the sections. First of all, for this particular page, they've got 3 short videos up here, and the purpose is that they're showing you different sound qualities. And notice this first one says good, the next one says better, and the third one says best. These are actually referred to throughout the reading. I'm not really sure why they stuck them at the top of the page. I also noticed that some of the quick checks seem to be out of place. They ask you questions before they've covered that in the reading material. So just keep that in mind. There seems to be some quirky issues with the ebook. And so my suggestion to you is to go through and read the material. And then maybe as you're reading and it refers to some videos, go back and watch those. And wait until you finish the page or cover the section to try and answer these quick checks if you're using those to check your understanding. Another reminder, these are not graded. They're just on here for your benefit to just check your understanding of what you just read. All right, so digital audio, it tells us here, is music, speech, and other sounds represented in binary format for use in digital devices. And we just discussed in the last section about things being stored in binary. And so we're going to see as we go throughout these 2 sections, and probably the last 2 as well, how things are stored in binary. And remember, that's zeros and ones. All right, let's see. Looking at how is sound digitized. Wanted to point out here that it states to digitally record sound, samples of a sound wave are collected at periodic intervals and stored as numeric data in an audio file. Those samples are converted into binary ones and zeros, which are stored in an audio file. So this kind of gives an example of how you might digitize a sound wave. So this line represents the sound wave, and this line is that same sound wave, but it's broken up into chunks. Okay, they kind of chunk it. Here they say sliced into vertical segments, and those segments are called samples. And each sample, the height of that is measured, and that height in what we see as decimal form here is converted into binary. And so this is what gets stored. And then when you play back that sound, this binary code is actually what constitutes that playback. So obviously the more samples you take, the better quality that your sound is going to be. And so that's what it's talking about here with sampling rate. And that is the examples of up here at the top that you can listen to, and just see if your ear can pick up the difference in those sounds. And it talks about that here, but again, those videos are played out up top. All right. Now, compression, we mentioned compression in the last section, and here we see that most music for portable media players is stored in compressed audio file formats. And here it refers to lossy, and it says that lossy, remember that loses a little bit of the code, but it reduces the size of the audio files, and so it also reduces their quality. But it also mentions here that casual listeners are usually content with the quality that's produced. All right, digital audio file formats. We're not going to take time to memorize all of those formats, but you're probably familiar with a few of these already. MP4, MP3, .wave if you've listened to sounds on the internet. I did want to point out, because I don't know if we've seen one of these yet, that some of these figures have a plus sign over here, and you can click on that and it will open that image in a larger view. Notice right here it kind of shows the pages, looks kind of ripped. that means that there's more image that you can't see. And so we see here that there are two other image types, sorry, not image, audio types that they couldn't fit here. And they just do that to conserve space on the page. So anytime you see one of these plus signs, you can make that larger. Let's see, I'm just going to kind of skip through this very quickly. I'm sure that you are familiar with downloading and streaming and on-demand services, so we won't spend time talking about that. MIDI is something that you may or may not be familiar with. Most people that have an interest in music are familiar with it, but in case you're not, digital audio is a recording of real analog sound signals, but synthesized sound gets created. It's created sound. And so this MIDI, musical instrument digital interface, is the standard way to do that. And so whereas digital audio files have recordings of real performances of people singing or playing instruments, MIDI files contain instructions for how to synthetically produce those sounds using zeros and ones. You guessed it. So these are a lot more compact than digital audio files since you are not actually storing a recording, you're storing the instructions. These files are typically really small. One disadvantage to using MIDI is that it cannot produce vocals. It can simulate a lot of musical instruments, but not vocals. And the quality of MIDI really depends on the playback device. And it mentions here that it's used a lot by musicians and composers. All right, digitized speech. Speech technologies are used to collect information from callers using telephone-based services such as directory assistance. I don't know about you, but I hate it when I have to call a technical support and I get a recording. And that leads me to another recording, you know, press 1 for this, press 2 for this. And so I get there. Oh, now you have another menu. Sometimes I go through 4 or 5 menus until I get what I want. And I'm like, I just want to speak to a person. But these things are getting more sophisticated as they work out kinks for them. I still, though, I just want to speak to a person. All right, speech synthesis versus speech recognition. So synthesis is where the machines produce sound that resembles spoken words, and recognition is like when you're talking and it recognizes what you're saying. We won't go into how all of that works. If you are interested, though, in how Siri works, they have a whole little graphic here where you can read about that. All right, and that ends section B. There's our little quick quiz for section B. Again, these are not graded, just like the quick checks. These quick quizzes are not graded too. They're just in there for you to check your understanding. So let's move on to section C on bitmap graphics. So I know that some of you are game design majors and you're probably having a lot of graphics courses. So hopefully you'll enjoy these little graphics units, although you may already be familiar with this. Again, this is the intro page, so we're going to kind of skip over that and notice that there's several vocabulary words in there. All right, again, you've got a couple of videos up here that I think that some of this may be referred to in the reading. So you may want to read it first and then go back and watch the videos. So here we see that as digital devices gain the ability to display images, 2 types of computer graphics evolved, bitmap and vector. So this section C talks about bitmap, and then in the next video we'll talk about section D, vector images. So right now, again, we'll just focus on bitmap. So what is a bitmap image? Sometimes it's called a raster graphic or maybe just bitmap. But it is composed of a grid of tiny rectangular cells called pixels. And each one of those pixels stores a color, which gets stored as a binary number. So this blows up a very tiny image of Stonehenge, and you can see these little pixels. If you've ever used the Paint program on your computer, which used to be so popular with little kids, you know, you could really zoom in and you could see these little pixels and go in and change the colors. That was really exciting several years ago. So bitmap graphics are used to create realistic images like photographs, and maybe also cartoons or images that appear in gaming. the desktop images displayed by your computer or your smartphone, all of those are considered bitmap graphics. Let's see, I wasn't going to cover any of that. Some common bitmap file formats. This lists a few. Again, you see another image here that you can click and read about those if you want to, but BMP, which are typically very large files, TIFF, JPEG, GIF, PNG, these are some popular formats for the web. And there are, advantages and disadvantages to each. You're welcome to read about those if you want to. Most digital cameras and your smartphones today, I see a lot of JPEG formats. Okay, so how does your computer represent this bitmap data? I think we just mentioned on the previous page as zeros and ones. So there are different ways, though, to represent the colors. They are stored in the computer as zeros and ones, but for our human brains, that's not really effective because we can't remember all of those numbers, these 8-digit codes for things. The easy ones we can, like maybe white or black. But if I wanted a pale green, there's no way I'm going to remember an 8-digit code for that versus all of the other colors. So RGB, red, green, blue, that is a very popular model that's used a lot on the web, and it's just the intensity of those 3 colors. And so each of those colors would get assigned a value ranging from 0 to 255 in decimal form, and then that would be stored in binary. And when you do the 1411 lab for this week, you will understand a little bit more about what that means and why that's the particular range of colors. Like, why is it 0 to 315? Again, when you do the 1411 lab, you'll be familiar with that. Let's see. So you can store colors in decimal base 10, hexadecimal base 16, or binary base 2. And if you're dealing a lot with colors, you have to know your way around those color systems. Let's see. So with 8 bits used to represent each color value, 1 pixel requires 24 bits. Okay, so that's 3 groupings of 8 because, red needs 8 bits, green needs 8 bits, and blue needs 8 bits. And so that's 24 bits total that you need. And with that combination, then you get 16.7 million unique color choices. That's a lot of colors. And it tells you here that that is known as true color. A little bit of a discussion about image resolution. Obviously the more pixels that you have to work with, the better quality your picture is going to be. And so it mentions a little bit about high resolution graphics. And then obviously those file sizes are going to be a lot larger too because you have more pixels in which to store. You can shrink and enlarge, but typically you run into issues with bitmap images. If you do that, you can get what we call a pixelated image, and this is a good example of that. You can also, if an image is really big and you shrink it down, you can lose some quality as well, although that's typically much better to take a large image and shrink it down than it is to take a small one and try to enlarge it. Okay, image compression. We've talked about compression already, and so this is just making the file be smaller so that it takes up less space, less storage space. And also if you are posting it on a website, it would take less time to download if it was smaller. If you're sending it via email attachment, it would take less time to upload and send. And so there are advantages to trying making your images as small as possible. And so let's see, I thought I was talking about lossy first, I guess not. So lossless, remember, does not lose quality. And so it mentions here just briefly that TIFF, PNG, and GIF formats don't lose any quality. And so I guess down below is where it talks about lossy. Yes, so I have a note here. I hope this shows up in your book. We already discussed lossless compression up here, right there. And so this is a typo. This is supposed to say lossy compression, and you can see here it's talking about lossy compression. So lossy does lose a little bit of quality, but usually it is not apparent to the naked eye. And so down here it mentions that JPEG and PNG are automatically compressed. Okay, to modify bitmap images, there are lots of things you can do to modify. This video is going a little bit long, so I'm going to kind of rush through here. Something called noise reduction, where you can take out spots and things. Image enhancement, where you might be able to take a dark photo and lighten it a little bit. And just a few other things that you may or may not have heard of, but you can kind of go through and read about that. Panoramic 360 images, these are becoming more and more popular. Most smartphones now have a pano feature with taking pictures. 360 images are become very popular, not just in like a gaming type world, but actual photographs. A lot of realtors are using 360 images to make photos and things of house tours now, so that people can kind of get the feel of the layout of the house without having to go and look for the house. And that's been really handy during the pandemic. I don't think, yeah, there wasn't anything in there I wanted to point out. Okay, let's see. This video is getting really long, so you can read, let's see, is this the end of it? Yes, it is. I'm trying to remember how to say this word. Stereoscopy. Yes, just in case you've not heard of stereoscopy before, you can read about that. But I'm going to go ahead and end this video, and I'll be posting one, should be right underneath here, of the last two sections of the book.